Okay, thank you, Maggie. My name is Natalie Mast. I'm the ADWR management plans, or the AMA director for the management plans at ADWR. We are glad everyone is here today. Thank you for everyone for attending. I'm going to go ahead and introduce the ADWR staff that we have in the room here, and then we can allow a chance for the committee members to also introduce themselves. So Tom already introduced himself, Tom Bushotsky, the ADWR director. We have Carol Ward, who is Deputy Assistant Director for Planning and Permitting here at ADWR. We have Ken Slowinski, who is Chief Counsel. And we have Amanda Long, who is the Management Plans Coordinator. So I'll go ahead and pause here for a moment for the committee members to also introduce themselves.
Well, this is Scott Riggins. I am the chairman of the Agricultural Water Conservation Best Management Practices Advisory Committee. Good afternoon, everyone.
Hello, everyone. This is Brian Hartman, a farmer from the Maricopa Stanfield area.
Hello, everyone. This is Noah Hiscox. I'm a farmer down here in Coolidge, Arizona.
Anyone else? All right, hearing none, we appreciate it. Thank you and welcome again, everyone. We did want to follow up quickly on one item from the last BMP committee meeting. We wanted to just thank those of you who sent any historical documents related to the BMP program. We did receive quite a few documents from SRP, so particular thanks to Dave for all of that. And I don't think we have any other committee updates. So with that, we can go ahead and move on to the next item on the agenda, which is a continued discussion of the individual BMPs, and I'll hand it off to Scott.
Tell him.
Scott, I think you're muted.
I was unmuted and I got muted, so I'm unmuted again. Pardon me for that. Did it stop in the middle, or was I just quiet the entire time?
You were quiet the entire time.
Okay, let's start all over again then. Good afternoon to everyone, particularly Director Buchowski and all these people that have been working with the BMP program, both ADWR staff and members of the regulated community for the last many months. We've had a great deal of things that we've discussed about this. Today is a very important day, in my opinion, because we actually are going to get down to nuts and bolts and discuss some of the aspects of the scheduling and point systems of the BMPs that we determined in the last meeting still had to be discussed. If all will remember, we went through the entire BMP schedule on our last meeting, and we determined areas where we were not having disagreements. So today, I am going to not really be discussing everything that we have decided we don't have disagreements on. We're going to intensively drop into those areas that concern BMP points and practices that have been remained to be discussed between all of us. I'll start this with, and if if staff can somehow get the fourth management plan, Appendix 4B, which is the best management practices worksheet, that would be a lovely thing to have up for people to look at as I'm going through, because I am using it as a framework of discussing things. And fortunately, there's somebody behind this screen that's doing things real quickly and knows where to look.
We're looking, Scott. We're having a few technical difficulties.
Not,
we're on it.
Not a problem. Not a problem. I think it's better if we have it up there for the discussion. And I probably should have asked Natalie to have it prepared, but pardon my various ineptitudes. And there we are. Very good. Thank you very much. And again, I apologize for not letting staff know that I was going to want that in the beginning. It would have made it easier. We're on the first page of Appendix 4B, which is the fourth management plan, best management practices worksheet. We have already discussed our last meeting that both the department and the regulated community has no problem whatsoever with Category 1. Category 1 contained no problems for anyone. There was a change in Category 1 of both the amount of points needed for the overall BMP and the amount of point value that was given to reflect that, and that all worked. So I'm going to go ahead and say that we finished ourselves with the BMP 1 category, the water conveyance improvements, and we'll go to where probably the bulk of our discussion is going to be today, which is in the BMP 2 categories, which are approved farm irrigation systems. To begin with on this, when we went from the third management plan worksheet to the fourth, the first four BMPs, BMP 2.1, 2.2, 2.3, and 2.4, they all had a actual reduction in points of each one of those BMP practices. Also, at the same time, there's a requirement to have more BMPs collected to be able to qualify for the program. One thing, the reason I bring this up, and it's not that I disagree with it, I don't have a problem that these have been reduced, but it's important to say why these things have an effect. Obviously, within the BMP that requires 2 points at least to even qualify for the program, anybody that has a farm of these 4 BMPs, they don't even qualify for the program. But what happens in the working of how points are tallied, very few farms have every single farm unit perfectly systemically improved. Oftentimes a farm will have a field or two that, because of depth of soil, because of type of soil, because of difficulty in conveyance, that have not been given the same level of improvement that the rest of the farm that gets full irrigation all the time gets. So by lowering these point values and increasing the overall point value that has to be achieved to qualify for the BMP, any farms that have a field or two that have much lesser system improvements, they have just been dropped considerably in what they can achieve in BMP category 2. And it makes it so that the preponderance of everything that's left absolutely has to be a very high value. So, and again, I'm not saying this is a bad thing. but it is something that has been changed from the last time. It absolutely 100% shows that the efficiencies and conservation that is mandated by the BMP program far exceeds any efficiencies or conservation that is available through the base program. This is another very durable concept that makes it so if things aren't efficient, they don't qualify. Now, moving on down, BMP 2.5 exists in exactly the same fashion that it exists in the third management plan, other than the fact that its 2 points now go to a 4-point goal instead of a 3-point goal. Again, same concept as was the above BMPs, that it makes it so everything has to be pretty darn fully systemically improved to be able to be in the BMP. BMP 2.6, high pressure sprinkler systems, indeed, same concept, no changes, exactly the same as it was prior. Its 2 points now have to apply to a 3-point system or a 4-point system as opposed to a 3. Starting at BMP 2.7 is where we start seeing changes. I have gone ahead and put these changes in an order that I think reads best. I haven't provided this as a visual aid for everyone because I intend to talk through them. So we'll take and put a break after BMP 2.6, and I have a new BMP 2.7. And I'll identify these new numbers. All the following numbers have to be changed after this, of course. The new BMP 2.7 is titled Non-Qualifying Low Pressure Sprinkler Systems. And in this concept is given 2 points. The definition of this BMP is a linear and center pivot sprinkler design that operate at water pressures measured at the high end of the main line of no greater than 10 psi and possesses any of the following disqualifying conditions. So we have here a low pressure sprinkler system that, if it's designed perfectly, has been given 4 points later on down. But this, however, is for non-qualifying low pressure systems. There are 3 different disqualifying conditions attached to this new BMP 2.7. Condition number 1, field slopes beneath a sprinkler system that exceed 0.25 foot per 100 feet fall along any bisecting line within a circle or in the direction of irrigation in a linear. So what we have stated here is that you can't put a low pressure sprinkler system on the side of a very steep slope and get any decent efficiency out of it. You have to have a specific point to where you're saying, if it is steeper than this, we no longer have an efficient system. In discussing this number with many, many people with sprinkler systems is where we came up with the 0.25 feet per 100 feet. Now, for the people that aren't used to working those numbers in their head, what that means is on a 1/2 mile diameter center pivot field of approximately 130 irrigated acres, that 0.25 feet translates into about 6.5 feet of fall over the entire 1/2 mile. So bear in mind that that same fall in a flood irrigation system would be very, very poorly designed, very poorly improved. But sprinklers have the ability to deal with some slopes better than flood irrigation does. And this is a number through a great deal of consultation that we've come up with. Again, if there is steep ground under a low pressure sprinkler system, it cannot be defined as efficient. So there is a new BMP that has been designated to carry it in. The next disqualifying condition, number 2, is a sprinkler system that lacks a mainline factory water filtration system that minimizes sediment and particle blockage and wear in the sprinkler regulators. Now, one thing that a lot of people that don't actually deal with these things understand is a center pivot or linear traveling sprinkler is a very complicated machine. Like any machine, it has a great number of wear parts, a great deal of problem areas, and needs to be maintained in such a way that all the aspects of it contribute to its design efficiency. To let a person understand exactly the magnitude of the issue of regulator blockage in center pivot systems, in a 1/4 mile long center pivot mainline, which would irrigate a 130 acre circular pivot, there are over 500 individual regulators. There is one every 2.5 feet along the entire system. Without adequate filtration, these plug and create ununiform irrigation conditions very, very often, more often than a person can check. So a design that lacks a factory filtration system to minimize those particulates is deemed to be a system that is not efficient enough to get anything other than the 2 points. There's too many problems there. Efficiencies are not good. They're hidden somewhat because it's harder to see it when you have a system like this. But nonetheless, you're getting areas that are over irrigated and under irrigated drastically. So this is included in the disqualifying conditions in a low pressure sprinkler system. Condition number 3 that has been identified to me by several people in the sprinkler irrigation field is a lack of an automatic main water supply pump shutdown system in the event of sprinkler forward travel failure. I have been told that one of the greatest short-term wastes of water that can possibly happen in a circular pivot system or a linear pivot system is when the motive power for the pivot fails. There's a whole lot of sensors that keep it in line. There's a lot of things that happen to keep that system moving straight. There's dozens of sensors that can shut that forward motion off. But there's a lot of systems that don't have the further conservation-oriented and safety systems that will turn off the pump. So a system that doesn't have the shutdown feature can have its forward motion stopped. And if it's in the middle of the night, or if it's a Sunday morning and everybody thinks everything's going right and nobody checks anything, dozens of hours can go by where this sprinkler just simply irrigates the same spot, doesn't turn itself off. These are very easily retrofitted systems that can be put on any center pivot system. Without it, it doesn't have the assurity of efficiency and conservation to allow it to have full low pressure sprinkler system points. So BMP 2.7 consists of a title, a definition, and then 3 disqualifying conditions. And it would be very unfair of me to read clear through this without stopping at each one of these and asking for any questions or comments.
Scott, this is Ed Martin with Cooperative Extension. I've got a question if I can.
Yes, sir.
So the other systems, the trickle system, the low pressure sprinkler system, the high pressure, why don't we have on those the same? You need to have some sort of filter on it because those systems after years of work, will wear down. And then also, why don't we have some sort of switch on those? I'm thinking on a subsurface or a drip system, you get a break in the line. If you don't know that there's a break there, by the time you see that giant puddle out in the middle of your field, a lot of water's gone through there already. So won't the folks that have those systems, shouldn't they have the same restriction as the one that you're proposing?
Ed, thank you very much for that question. And your points concerning how this affects trickle systems, we just haven't got there yet. And I will address those exact points there.
Okay.
Now, your question concerning why doesn't a high pressure sprinkler system have these same considerations? Well, that's a valid point, and I won't say it's not. The difference is that a low pressure sprinkler system, if it's in a totally qualifying condition, is available for 4 points. Whereas a high pressure sprinkler system is never able to get more than 2 points.
Gotcha.
So I would say that certainly it could also apply to high pressure sprinkler systems. But if that's the case, then where do we take it down to?
Right.
Do we make it less than a unimproved flood irrigation system? And the other thing is, high pressure sprinkler systems include something that low pressure systems don't, and that's solid set designs. And solid set designs, even in the third management plan, got some additional points for what they do further on in the BMPs. So in looking at this, my thought was to leave high pressure alone at 2 points and work with the high value systems to where if they don't use best technology to do what they need to do, or there's 2 reasons why center pivot and linear systems get used. One is because someone's looking for a very efficient, very conservation oriented system. Another reason they go on is sometimes it's a lot cheaper on very steep ground to put a pivot in than it is to level the ground. Well, that doesn't mean that you have a real efficient system. So this is one of the reasons why irrigation fall underneath the system is very important to quantify. Because just because you have a low pressure sprinkler system, if it's on lousy, huge fall land, it's not efficient, not at all. So it was important to put this concept in there.
Okay, thank you.
Okay. Anyone else?
Scott, we do have a question here in the chat box from Brian Betcher. He's wondering, what about effective soil types with first soil exclusion for the new 2.7?
Let me find that so I can read that. Okay. The largest situation that occurs with higher slopes underneath a sprinkler system is that as the slope increases, the tendency of the water to run off is greatly enhanced. So you've got a water flow way in front of the sprinkler, and it's not getting into the ground. Now, there are effects with soil types with sprinklers. However, it's not as large as it is with flood irrigation systems, because you can adjust the speed of the sprinklers, you can do various things, you're trying to use less water, and it doesn't run off quite as fast on a clay system with a sprinkler as it would a slope system. That's one aspect of it that wasn't included into the concept. The other aspect of it is, if we put soil types in with sprinkler systems, don't we then have to put them in with level systems and trickle systems? And one of the great controversies when this BMP worksheet was finally approved a long time ago, many years ago, was you just couldn't get every point there was in it. I mean, there were a few things there that you just had to recognize had to be included in the definitions and how it was ranked. So again, on that, I don't disagree that there is an effect of soil types, but personally, I don't think it would be right to include it in this non-qualifying low pressure system without also figuring out how to put it into every other kind of system. And I don't know if we want to go down that road.
Scott, this is Director Bashowski. I have a question.
Yes, sir.
So in relation to the discussion just had about the soil types, how readily available is that information to the farmer? And if we put soil types in here, is that going to be a huge burden for the farmer to determine and report the soil types to DWR?
I am very glad you asked that question, because all of this stuff has levels of nuance and difficult detail that make things much more difficult to understand unless the questions are asked. And thank you for asking that question. There are available base level soil horizon maps for pretty much all the irrigated land in southern Arizona. They were done back in the 60s or the 50s. They actually were quite useful back then because they led people to better areas to farm, to better soils to farm with limited water, best places to put things. And if we were still in the condition of base agriculture of 60 years ago, they would still be helpful now. But what has changed everything, and there is no documentation you could ever find for it because it doesn't exist, is land leveling. When you level land, you mix all these horizons up. You come up with something that is not the same as it was. And oftentimes you have fields that were pretty uniform soil to begin with that become not that uniform after you've leveled them. Now, getting the slopes down to very flat can work well, even though you have these different soil types out there. But to have reporting on soil types, you know, I don't know, just myself, I have maybe 60 field units that I farm that every single one of them has been leveled extensively. I wouldn't know what to put down on a sheet that asks for that.
Thanks, Scott. And I guess my follow-up to that is, if you decided to put that requirement in, given the amount of work it would take to do that, and maybe the expense as well, is it worth the bang for the buck, so to speak, I guess is my question. I'm not looking to really, I'm not looking to add requirements that don't have some reasonable bang for the buck for water savings.
And I myself, as I worked through these things and tried to figure out both those things that absolutely had to be included and also those things that absolutely shouldn't be there, and then that middle level of things, what if? And usually the what if things usually got thrown out of the consideration because they engendered more difficulty and complexity than they helped. So my statement is my original writing of these things, I felt that soil types did more complexing of the issue than they solved.
This is Noah Hiscox. I'd like to just add a comment if I could, please. I'd like to just input that when you're ready to improve your irrigation system, you generally start with NRCS or IMS. And what you're about is what you can affect. You can't change your soil types. You're saddled with them. You can change the system to improve the irrigation, but you can't change your soil types. And as Mr. Riggins has already stated, when you go in and install a level system, you will change in that very field the soil types again, but you'll have to deal with that afterwards. So I think it would be just way too complex to include soil types. Those discussions need to happen before you decide on what system you're going to install. And afterwards, you really are just deal with the differing soil types at that time.
Any other questions?
Chairman Reagans, this is Brian Hartman.
Yeah, yes, Ryan.
Just to be clear, so on this new 2.7, it deals with the low pressure system with 10 psi or less. The first qualification, the first disqualification would be the 2.5 feet per 100 feet of fall. Is that correct?
That's correct.
Okay. Even the only question I have, it came up with soil types. You explained that, but it just seems like those of us on sandy hill type farms, we can speed up to compensate. And like in our area where the alfalfa grows up, we get more organic matter, more plant material, and it kind of slows down the water. Of course, we never want to have water run off our field. We'll shut the system off or speed it up, excuse me, to compensate for it. Those are just some of my thoughts on that.
And I appreciate that capacity that exists within the system to do those things. In speaking with a large number of people with sprinkler systems, just asking the question, does land underneath sprinklers, can it get steep enough where you can't do an efficient job uniformly irrigating crops? And every single time the answer is yes, it sure as heck can get too steep. So then the question after that is, okay, so what is that steep? Now, let us understand, we have a system here that is based on best management practices to create the very highest efficiencies and levels of conservation that are possible. So we're not looking for a fall where things are okay. We're looking for a roll fall where things are very good to excellent, because that's what it takes to get 4 points. That's what it takes to be a full best management practice of the highest design. So we're not just looking for a middle ground of what's okay. We're looking for excellence. We're looking for what is good. And there's still points to be had if there isn't, if it's steeper underneath it. It's not that the points go away. It just is no longer something that is classed as very good and excellent.
Scott, we do have a question in the chat box from Jimmy Fox. He's commented,
Okay.
Why is the high pressure system penalized? The rate and speed of the system determines the rate of infiltration. A high pressure pivot that runs at a higher rate of speed will have the same infiltration rate as a low pressure, low speed pivot.
Well, the reason high pressure systems are penalized, just like they were in the very beginning in the first BMPs, and the reason why currently sold and designed center pivots and linears are all low pressure systems, are simply from the aspect of a high pressure system wants to throw water a longer distance with higher pressure, and so your rate of in-air evaporation is much higher. That's why they went to low pressure systems. is because high pressure systems have a lot of evaporation. You have a lot of very small water droplet sizes that are very, very subject to evaporation, wind blow, all sorts of things, whereas a low pressure system, it has great big, droplets or even continuous flow that basically flows straight down. It has a deflector that hits when you look at a nozzle on a low pressure system, it's just a hole, a pretty good size hole. It runs down and hits a diffuser plate and runs to the ground. So that's the reason why there's the two different systems. They can run on the same mainframe, but it's the delivery of the water at low pressures that holds down the evaporation. Any other questions? Okay. We'll now move on to, again, let's remember that all our BMP numberings are different because we've inserted things in here. This will be the new BMP 2.8. And its heading is non-qualifying trickle irrigation systems. And they are worth 2 points. They are defined as pressurized drip or subsurface irrigation systems that possess any of the following disqualifying conditions. Condition number 1, any installed drip tape or drip lines that are over 10 years old. A drip system, for it to be efficient and be fully cognizant of highly advanced conservation, must be uniform. And drip tapes that get too old are definitely not uniform anymore. In fact, their inefficiencies are baked into the cake. Those older lines, absolutely, there is unless there's a break in the system, it's not that there's places that don't, there's places that over irrigate. I mean, the holes don't get bigger generally. But what happens is there's lots of places where the holes get smaller. And so the field unit has to be watered for those areas that put out the least water, or you have areas in the field that die. So by definition, that no longer is an efficient system. Just because it's trickle doesn't mean it's efficient. Trickle has all sorts of problems that can happen with efficiency and uniformity. The thing of it is, they're just usually happening underground where you can't see them. But it is a fact of life that older drip lines are very inefficient. So any drip lines that are over 10 years old would not be an efficient system and would be deemed a non-qualifying trickle irrigation system. Condition number 2, lack of a system to visually or through pressure measurement check all lateral and other diversion valves for leakage. This is a problem of really enormous potential. If you have a 500-acre system of drip lines, laterals, mains, you have an enormous number of valves, just an enormous number of valves. Any of you that have lived in a 10 or 15-year-old home know that your water valves kind of have all sorts of problems and cause you all sorts of difficulties over time. Well, these valves also do the same thing. There's valves all over. The big problem is that in a conventional, fully PVC'd, non-visual inspection system, if a valve leaks and bleeds off 5 or 7% of the water going down a line, all that water does is go out into a buried drip system and no one ever sees that it happens. Unless you have a way to check those valves, you have every ability in the world to bleed old valve waters into systems that are underground, will never darken the ground up because there's not enough of it. And so you're just losing that water. you only gain so much efficiency in a trickle system over a level system. You have some leaks like that and you've lost it all. It's all gone. And if there's a lot of them, it's gone a whole lot more than that. So without a system in place to be able very periodically, without much effort, to check your valves, every one of them, you have a system that is not efficient, is not mandated to be at the top level of conservation. So this is our condition number 2. Condition number 3, we had a comment concerning drip lines and what happens, Ed brought it up, what happens when they leak, you know, when there's water running around. Well, those of us that have spent time studying and observing or having trickle systems know that leaks are a huge problem. They can in fact be devastating. Now, the fact of this issue is that generally, these kind of leaks occur through either tapes getting older, cracking, maybe being hit by a subsurface implement, oftentimes being predated by rodents and other things that might want to drink water out in the system. So exactly how to write this to say how important it is to not let these things happen was difficult. This one was, I believe, the most difficult one I wrote. I spent a lot of time trying to think through it in such a fashion. And I will give you my opinion on the way it should be worded. This unqualifier number 3, and it states, lack of organizational policies for management and labor that assure that all visible leaks in drip lines and related systems are repaired within 6 hours, and in no event shall leak waters leave the perimeter of the field unit. So that is the new proposed BMP 2.8, its heading, its definition, and its disqualifying 3 conditions. And it is worth 2 points. Any questions?
Scott, Director Bashofsky again, and this is again kind of an administration question. So on a BMP farm that's reported to DWR, in relation to the first non-qualifier, the 10-year-old tape or less, in reality, is that one BMP farm going to be homogeneous in a way that the whole farm is going to have the same age tape? And if not, at what point do you get to a percentage of that tape older than 10 years where the disqualification kicks in?
Actually, BMP category 2, the way its points are accrued are predicated on taking every field unit, ranking it, and then coming up with your overall point structure. So if you had 4 field units that had 5-year-old tape and 1 that had 10, well, the 4 would get 4 points if everything else was correct, and the one that had older tape would get 2. And that would be calculated into the way that all the rest of these BMPs are also averaged in that same fashion to come out with the eventual number for farm category 2.
So Scott, I'm not familiar enough with the reporting requirements. So when a report comes into DWR, does each field unit get reported?
When the original worksheet requires, let me see, I don't think you guys ever produced the actual, not the worksheet, but the actual form. But I'm looking at the 3rd management plan form, and under irrigation systems, it begins every single one of the BMPs is listed, And then there's a percentage of your farm. So if you have a 400-acre farm and you've got 40 acres that is one particular design, that's 10% of your BMP score. And each one of those systems, you know, if you've got, of your 400-acre farm, you've got 200 acres of another BMP, that's 50%. And so every single field design is accounted for and ranked and put into the weighted point value for category 2. So that the question you asked, the entire BMP2s, they do it that way anyway.
Chairman Reagan's, Brian Hartman here.
Yes, sir, Brian.
Yeah, Chairman Reagan's, I just wanted to back you up on the leaks. We used to have drip, and the older the system got, the more the gophers moved in, and we tried to control them, and they just chewed through that tape, and it was just a nightmare, labor and management wise, to repair it and keep it going. And we eventually had to abandon the tape and move towards a pivot system. So I wholeheartedly agree with you on the leaks.
And thank you very much for that comment. In my own observations and discussing with many people, particularly, you know, in Pinal County, most of the drip systems have been over in the MSIDD area. There is a part here in Hocam, one of the original pioneers had a big bunch, but there is a great deal of observational discussion of drip fields that ran so much water out of the fields into the bar ditches, it was hard to believe. You know, and that seems like, oh, how does that happen? Well, the way that happens is very high level management and labor policies and systems to prevent it from happening. And it's tough. It's a tough thing to do. So I very much appreciate your observations.
We have a question here from Brian Betcher. He's wondering,
Okay.
how would you propose to monitor or enforce the third disqualifier for a new 2.8?
You know, every one of these BMPs has challenges as far as verifying what's going on. Some of them are easier than others. And in writing this, trying to figure this out, this is one of those situations that a person with BMP that wants to have trickle irrigation systems at the full 4-point level, just like, for instance, let me give you for instance, before I say what I was going to say. In level systems, BMP 2.8, it states right on it, all irrigation water, either all irrigation water is retained on the field or a level drain back system is used. Well, we just put the same concept into trickle. There can be no leak waters leave the field. It's the same concept that we're utilizing on level systems. So, you know, if there are leaks out there, if these things are going on, there's physical evidence that can be found of these things, and also information gets around. ADWR, if they are going to perform an audit, they need to look at these things that are a little bit more subjective along these lines, ask questions. Obviously, if a person wants to have a 4-point trickle irrigation system, they're going to have a written policy that they have that's enforced by what their management is, and also their labor requirements and what they've provided. You know, it's just like when we have BMPs that say that you have you're forming your rows, you're flattening and forming your rows. Well, how do you verify that? Well, one of the ways you verify it is that the person has to have the equipment. You have to be able to see out there that it gets done periodically. There needs to be certain concepts that we discuss that will be very diligent on exactly how we do some particular aspects of verifying audits. Some of these things are really quite easy. Other ones are a bit more subjective. I would suggest that what's been written in this number 3 for non-qualifying trickle systems, I would suggest it's no more subjective than some of the other ones that we have in the BMP list. And a good discussion on exactly how that we want to quantify that for audit is one I would be welcome to have, because I think that's an important part of this program.
Scott, question here from Kevin Rogers. He's commented, will you provide your suggestions in writing for us to review more in depth? Are we making this very complicated?
I absolutely intend to provide all this in writing. I intended to give it to Chelsea to distribute on the regulated community side, and I intended to provide it also to the department after we've gone through this. I wanted to go through it verbally the first time because I wanted to engender conversation. But yes, absolutely we'll do this. I also can tell you that it'll probably be the middle of next week before I take all my handwritten notes and get them on a Word document that you'd all want to look at. So it'll be a few days in the next week, but then we will get them out for sure.
Chelsea McGuire has commented, thanks, Scott. We'll be happy to distribute. And a member of the department.
Thank you very much, Chelsea.
A member of the department commented that we can make it available on our website as well.
Okay. No, that is absolutely the premise here, is to get this totally out. No doubt. Any more questions at this point on non-qualifying trickle systems?
There are no more questions in the chat box at this time. Okay,
very good. Thank you very much. We will move on to what is now BMP 2.9. It was the former BMP 2.7. It is near-level systems. The definition remains nearly the same. One of the things that we need to talk about with both near-level systems and level systems, when the original BMPs were formatted, there was a large representation of people that had worked with the former NRCS, then it was SCS, over a concept of high volume, flat level basin irrigation. And it was a good concept. There were a lot of things about it that worked very well. One of the problems with it right from the beginning, though, and in Pinal County and the Pinal AMA, there were always problems with it, is not everybody has high volumes. Slopes, when you're running a 15 CFS head into a 200-foot border, it's a great deal different, when you have a 2 CFS head. Slopes are one of the things that you use to manage that. And we know, everybody in the regulated community by now should know, and the department certainly knows, that over the next handful of years, the entire Pinal AMA is going to lose its very large head deliveries. They're going to be gone. The age of 15 CFS deliveries in the CAP districts will not be there anymore. There's going to be a lot of systems that were designed for 15 CFS deliveries that are actually going to go out and have to redesign themselves because they will not be able to operate with their identical systems in the new paradigm of reduced head sizes. So with that being said, near level systems are systems that have slightly more grade than level systems, not because they wish to spend less money in doing the leveling. That isn't what it is about. What it is about, it has to do with road length, field length, how many hundreds of feet long is a field. It has to do with head sizes. It has to do with soil types. So there are times that a slightly higher grade is very advantageous. Now, will that be as highly uniform? Well, it can be as uniform, but will it be as efficient and conservation as a system that is near level? No, it won't be. So here's what I've proposed in the near level systems with the caveats that I've just been given. The original point value in near level systems was 2.5 points. Now, by going from a 10 point to a 12 point system, by retaining the same point value on near level systems, what we've done is we've diminished it. We've made it be less valuable, which does not apply. That is not a correct interpretation. The way I've written this, near level systems will be worth 3 points. And there's a change in the definition. One of the systems that were used with high volume, nearly dead flat systems was the concept of total fall in the direction of irrigation. Well, the problem with total fall is all you have to do is change the length of the run and you change the fall. So those of us out here that actually level things and irrigate them, total fall to us is a measurement of how many feet fall per 100 feet. So the way this definition I propose reads is slope fields that have an engineered to uniform grades between 0.03 hundredths, or actually that would be 0.31 feet to 0.06 feet per 100 feet. Now, to put that in layman's terms, taking the math out of it, on a quarter-mile field, the 0.031 fall for a quarter mile, that field would fall 4.5 inches, which is very slight. The higher end of that would be 8.5 inches of fall in a quarter mile. Those grades take into account longer runs. They take into account coarser or uniform soil types. They take into account smaller irrigation heads. The smaller irrigation heads are a distinct new challenge that we weren't considering in the third management plan. And smaller heads have to be taken into account in our new descriptions, definitions of near level and level. So at that point, I'll ask for questions on the concept of near level. Okay, we'll move into the next BMP, which would BMP, now it's 2.10, and it is level systems. Again, in the system that we have here, level systems have been diminished in this fourth management plan worksheet by retaining the same number of points it had in the past and upping the number of points required. So it's actually been diminished. The preponderance of highest level irrigation systems, the state of the art, the Cadillac, the most expensive systems that there are, because they're permanent and they're visual, are level systems. Level systems operate with a continuing efficiency well in line with the same efficiencies as good low pressure sprinkler systems and good trickle irrigation systems. So the new point value for level systems will be 4 points. It has the same issue with getting rid of total fall. And the way the new definition would read is level border or level furrow systems where the field slope may vary from 0.0 to 0.03 feet of total fall in the direction of irrigation over the entire length of the field. And again, either all irrigation water is retained on the field or a level drain back system is used. So again, to take this into how much fall we're talking about, on a quarter mile, 0 is very simple. There's no fall. And the maximum fall that can be allowed in a level system is about 4 inches, 4¼ inches. That's it. You know, the department has heard me say, and I'm sure there are a lot of people out there with experience leveling. I have actually taken field units and made them level on a quarter mile because that was supposedly the level of conservation we were trying to attain, and found with the length of run and the infiltration rate of that particular soil type and the head size I found that I actually made it use more water, not less. So I have found that in my soils with my runs and my irrigation systems, not every single field is that way, but generally 0.02 or 0.03 is where we level to because it's best. And we know that empirically because there's a lot of fields we've irrigated or leveled 3 or 4 times. And we look at them and make decisions based on what's happening. So that level systems then, the difference between what was on the 4th management plan worksheet, it now goes to 4 points because it is totally on par with qualifying low pressure sprinkler systems and qualifying trickle irrigation systems. And also we have changed the definition of total fall to one of per 100 feet. By the way, just something to know, again, as interest, in an 1/8 mile system, 0.03 feet does not exceed 0.2 feet. So a field that's 1/8 of a mile long, the 0.03 still meets the definition that we had before. But particularly when you go out to quarter mile fields, oftentimes that 0.2 feet is just not enough. It needs just a little more. And again, it must be understood. That's not done to economize. It's done because it's better. The level of conservation, the efficiency, the entire system is much better for both production and the conservation of water resources. Any questions?
This is Noah Hiscox, Chairman Riggins. I'd just like to make a comment. In the Coolidge area, we generally level our farms at a 0.02 per 100 feet of slope. But I've also leveled farms down in the Eloy area, one that the soil type was very high in granite. The intake rates were so high that to get the correct amount of water into the soil, we leveled those farms at 0.05. Now that intake, that slope was recommended in the design by NRCS because we had taken soil samples and tested. Had we not leveled that at a 0.05 slope, it would have been the amount of water it would take to irrigate would have been in great excess, and it would have been totally inefficient. To help people to understand, 0.02 on a quarter mile run, we'll call it 1,200 feet. It's 0.02 times 12 inches times 12, which is 1,200 feet. The difference from the the head end to the bottom end is only 2.88 inches. Well, on that same farm I was referencing down by Eloy that we leveled at a 0.05 slope, that slope from the upper end to the lower end was 7.2 inches. Seems excess, but in fact was absolutely perfect. So if that helps put that in perspective for everyone, that was my goal.
Just to comment on this concept, one of the strengths of a center pivot sprinkler system is the ability to speed it up or slow it down. You can make its travel across the ground with a given head size running through it faster or slower, which means you can optimize the situations that you're trying to irrigate into. It gives you control, which gives you the capacity for more conservation and more efficiency. In a level system with given soil types, you can have very, very high efficiency, and adjusting for the soil types is obtained through a small change in rowfall. So again, you are refining and perfecting the system and making it better. 0.1 or 0.2 or 0.3 extra, 0.0 to 0.03 extra feet per 100 feet can make a great big difference in making a much more efficient and conservation-oriented system. And it's very important to understand, it's not done to economize. It's done to maximize. The best designs use those concepts.
Scott?
Hey, Scott, I see that. Sorry,
Yes,
go ahead, Director.
Yes, Director.
Yeah, Scott, this is the director. So with the discussion that led into the current 2.7 and 2.8 about higher heads going away because of the Colorado River water issues facing us, is the change in the level system fall from 0.2 to 0.3 something that will incentivize leveling systems, using level systems with the lower heads that are going to come in the future? Is that what you're trying to do? Is that what is the result of that change?
Two directions. First of all, we're not just taking it from 2 to 3. The way that it is specified now, it is 0.2 feet of total fall for a field unit, regardless of what the length of the field unit is. So the definition resulted from a time that technology going full flat and huge head sizes, that's where that definition came from. It has been long ever since it was put in place, because there are times that there are soils that need a little bit more fall than that. And as I say, it's an engineered concept. You know, when you take 0.2 feet of fall, that's roughly 2 3/4 inches, and you put in 0.03 feet of fall on a 1/4 mile, you're roughly 3 1/4 inches, 4 inches. It's a very slight difference, but it makes a huge difference in the way the water flows. So we're doing two things here. Number one, we are correcting a technology concept of 25 years ago. More than that, I took a field trip with the University of Arizona in 1980, so that's 40 years ago, to the Welton Mohawk, so we could look at the first laser levelers and their level basin systems and their huge delivery Arcos delivery systems. That's 40 years ago. So that was the desired technology at the time. Well, it's proven to not be the best, because not everybody can run with huge head systems. All of us with independent wells in the Pinell AMA, we never had. Our head sizes now are the same size as they were in 1950. You know, they're no difference. And those definitions don't fit the reality of the preponderance of irrigation systems in the AMA. And those that it does fit, they're about to have a reckoning, because these definitions do not work when the districts have to cut their head sizes back. Indeed, I have sat on the Florence Coolidge NRCS for years, which is the liaison organization that deals with the NRCS. And we have tried for 2 decades to tell people, don't design your fields for 15 CFS, because you're going to have to redesign them at some point in time. Well, a lot of people did anyway, and now they're going to have to redesign them. It's going to be a big issue. There's going to be a lot of slope fields and a lot of border sizes and a lot of head gate placements, a lot of things that are going to have to be put back into these systems when this water volume delivery changes. And the change in definitions totally reflects those 2 concepts. One, the fact that it was a technology that absolutely depended on high head sizes, when indeed lots of places didn't have head sizes. And 2, pretty soon nobody's going to have high head sizes. So that's the answer.
So the second one, Chairman Riggins, is just an observation. The proposal for near level is to raise it from 2.5 to 3. The proposal for level is 3 to 4. Those increases are of a different magnitude, a larger magnitude for level systems than the level of increase you're proposing for the near level system. And not just, I'm not just talking a half a point versus a point. I'm talking the percentage magnitude, right?
Well, I concur with you. The near level system was raised from 2.5 to 3. But by the same token, low pressure sprinkler systems were raised a full point. Trickle irrigation systems were raised a full point. High quality, best engineered level systems irrigate at virtually the same place, all concepts considered, as the 2 systems that have 4 points. And that's why level systems were also brought to 4 points.
Okay, thanks for that explanation.
Thank you, sir. I see on the chat that Mike Caparasso would like to comment. Is Mike out there where he can?
Yes, I am.
Well, yes, please go ahead.
Thank you. I'm trying to even show my face here on the video, but doesn't seem to be working. Okay, Scott, Mr. Chairman, I completely concur with your analysis of the level basin systems. I want to back up a little bit on some of your historical comments about, well, Mohawk. I had spent 5 years down there designing level basin systems. And I also spent 15 years with ADWR, part of it developing the BMP program before I left in 2001. But anyway, regardless, what you're providing here is the ability to compensate in design for variations in, like you said, field length and in soils. Something that the NRCS, who I also worked for 7 years, advocated in their design charts for all irrigation systems. So basically what I'm saying is level basin systems, I think, at least in agricultural sectors in Arizona, are probably more achievable than any other system available out there because of cost and field layouts and whatsoever. I'm a real advocate of trickle irrigation systems if they're managed properly. I'm a super advocate of any kind of sprinkler system under low head pressure. But if you're looking at costs and you're looking at the majority of the systems in Arizona, most of them are flood irrigation. And that said, the level systems are the most efficient, as we all know. Now, allowing a greater fall under proper design is an excellent opportunity for farmers to achieve higher irrigation efficiencies. So I would suggest, basically not suggest, but I would support that you're raising the BMP points for level system, and even a half point for near level system, that matter, is appropriate, mainly because if the system is not designed and operated properly under these two systems where the water is all retained to the field, there is no water runoff now. There's no other opportunity for that water to go anywhere but to remain on the field. Well, that has to be regulated, managed properly from an irrigation water management standpoint. And probably you know better than anyone that if you over irrigate those systems, you get scalding, especially in the summertime at the bottom of the field, and you lose your crop. So those things said, I just wanted to comment and extend my support on your interpretations and your findings over the years of providing an operator's perspective on these types of systems. And that was basically my comment for now.
Mike, thank you very much for that clarification. And also, if I spoke in such a way to where I made it seem that I was denigrating in any way the work of the Soil Conservation Service in those years, I do know that their designs, and as Noah Hiscox stated also here, their designs absolutely bring in length of run, soil types, slope, all those things are put together for best case analysis. Sometimes systems get cost shared and they get descriptions and they get qualifiers that sometimes take the best directions that SCS tried to do, and they somehow kind of went in certain directions that weighed things a certain direction, mostly because of what operators desired. But I in no way wish to make anyone think that I was denigrating SCS, because I think they do a fabulous job, and they do totally take into account all those concepts. But thank you, Mike, very much for your comment.
Chairman Riggins, this is Director Brashofsky again. I have another question. So in the conversation about the unqualifiers for low pressure sprinklers and trickle, the factors seem to be partly mechanical and partly management. Are there similar mechanical, management, or other challenges in the level system design and operation that would potentially reduce the efficiency of that level system design?
Any irrigation system, regardless of the expertise and proficiency of its design and execution, can be made to be inefficient if it's not ran properly. I don't particularly know how to put in the concept of that, you can't make a mistake. Management is very, very important, but there is obviously the people that have spent the monies doing the things that they are doing here, they have a financial incentive to manage this as best as they can, not just a regulatory incentive, but they have a financial incentive. They want their bill for electricity or for water to be as low as it can be, and they want their crops to be as uniform and well producing as they can be. So there are incentives in that direction. When we look at the non-qualifiers in, let's say, in sprinklers, well, one of the things that we have in sprinklers is some of those things that'll really degrade efficiency, you can't see. I mean, when multiple regulators aren't putting out the same amount of water, it's not that you can see a great big stream someplace and a little tiny stream somewhere else. It's less pronounced than that. They're invisible. So the qualifier that you have to do everything you can to filter to prevent that problem as much as possible is something to prevent a problem that can't be seen. One thing about surface systems, you can see what's going on. It's visual. You can see it right out there. You know how it works. Likewise, the concept of the shutting off the water pump in case you have a failure to travel. That can go on and in the middle of a center pivot system hardly cause any problems at all. Well, if you have that same thing happen in a flood irrigation system, you might cut across 3 or 4 benches, wipe out 4 ditches, and have the county get after you for taking their road out. There's different levels of problems that work with the different systems. Systems that are visual 100% are easier to manage the fine points. They don't require the checking. Same with drip. The things that are mandated in both the first and second condition, they're invisible. You can't see them. They're being mandated because they're more difficult to check. They're more difficult to understand. And drip is very unique in that it has the potential for very high efficiencies and also at the same time the potential for enormous waste if the breakages are not controlled. And I haven't talked to an operator yet that didn't say that it wasn't so bad the first few years, but as it got older, it got to the point where we just couldn't stand it anymore and we changed. Trickle systems, they have their wonderful aspects, but they have their difficult spots just the same. But that is one of the reasons why some of the different concepts is that level systems are totally visual. You can absolutely see what's going right and what's going not. You can't on the other two. They're unique technology to know how it's going. Any other questions? Okay, your battery is running. Oh, that's somebody else's battery. Okay. We will move on to, these two are short. They're easy. This is the new BMP 2.11, and its definition is a qualifying low pressure sprinkler system. And it has 4 points. And its definition is linear and center pivot sprinkler designs that operate at water pressures measured at the high end of the main line of no greater than 10 psi with none of the disqualifying conditions enumerated in BMP 2.7. So it basically change from what it is. It just states that it doesn't have any of the problems that 2.7 has. I'll just go ahead and move right on to 2.12 because it's the same thing. It's qualifying trickle irrigation systems, and it's the same definition: pressurized drip or subsurface irrigation capable of applying precise amounts of water to the crop root zone, also referred to as drip irrigation, with none of the disqualifying conditions enumerated in BMP 2.8. So those are the same as they were. There hasn't been a change with those. And that would be the end of the BMPs for Category 2 approved farm irrigation systems. Any questions at this point? Okay, very good. That was the biggest part of what we're doing. There's changes in the others, but they're not as large as what we just went through. We will move over now to category 3, the irrigation water management portion. A couple of small changes on BMP 3.1. It was pointed out that not all leveling anymore is done with a laser. It can be done with a GPS. So the change to BMP 3.1 would be a simple verbiage change, a laser or GPS touch-up, point value the same. A definition would change from annual reestablishment of precision laser grade to precision laser or GPS grades. And then also where it states right after that, to ensure good advancement, that word good should have always been uniform. Good is a subjective term, uniform is an objective term. So that's the only change to BMP 3.1. Stays the same other than a couple of small changes because of technology and changing a word to uniform as opposed to good. Any questions on 3.1?
Chairman Riggins, again, Director Bachowski. So in the last discussion of category 2, we had some unqualifiers that reduced the points.
Yes,
Those
sir.
unqualifiers related to situations where the efficiency would go down, and the unqualifiers defined what would cause those efficiencies, I guess, to go down.
Yes,
So
sir.
the laser touch-up, it's really part of the level field in number 2, correct?
Yes. No, well, it is not. I have 2 other BMPs to insert under 3.1. Any irrigation system, high efficiency irrigation system, just like a high efficiency race car, it must be tuned up. It is not put in place and then stays that way. Any system requires maintenance. And if you'll let me finish with 3.1 and then say my proposal for 3.2 and 3.3, I think it would be better to have the conversation, what you just brought up, on all 3 of them at the same time.
Good enough. Go ahead. Thanks.
Okay. So we have BMP 3.1, which is where an operator goes out with a laser scraper and totally reestablishes, fixes all the little holes, fixes the tillage marks, fixes all the things that cause a little less uniformity, and has to do it on 20% of the near level and level basins every single year. That means every 5 years, the entire farm is re-leveled on those systems. That is a very, very high level of maintenance and produces very, very high efficiency, very, very wonderful conservation systems. I have a BMP, a new BMP 3.2, and its heading is low pressure sprinkler system annual maintenance. It is 1 point. It is defined as annual maintenance programs on all individual sprinkler systems serving irrigated acreage within a BMP regulated irrigation right. This annual maintenance regime must be dealer or factory specified, broadly based inspection and replacement program performed by a dealer, qualified service agent, or by a BMP operator under the guidelines so specified. So here we have, just like in laser touch-up, we have the ability of the operator who is going in with a very high level of maintenance to his sophisticated and high efficiency tool and making sure it is absolutely tuned up to where it needs to be. You know, it's hard to imagine, but in a section farm, 640 acres that has 4 pivots on it of 130 acres each, there are 2,000 regulators in that system. There are 2,000 nozzles of varying sizes. There are dozens and dozens of electrical interfaces, computer interfaces, lots of technology to get all that stuff to where it is truly and fully efficient. And by giving a maintenance benefit of this high is something that is along the same lines of the efforts. It's not nearly as expensive, by the way. Laser touch-up is a lot more expensive than this would be. But this is not an inexpensive thing to do, but it shows an absolute commitment to maintaining the efficiencies that were started when these sprinklers were put in. And I'm going to go ahead and read this next one on Trickle too also. I'm not wanting to bypass anything. I just want to have the 3 of them there as a block. The new BMP 3.3 would be called Trickle Irrigation Advanced Maintenance Drip Tape or Line Replacement Program. And it also is 1 point. Now, let's recollect that if drip tape gets 10 years old, a drip system no longer qualifies as a qualified system. It gets half of its points, and then it only has 2 points after 10 years. And we also know that it's not like the degradation of these drip tapes all starts you know, at 8 years and everything's fine up until that point, because we know that's not the case. So this 1 point program is defined as drip tape or drip lines being replaced 5 years after installation on 20% of all irrigated acreage served by trickle irrigation within a BMP regulated irrigation right. Every year thereafter for another 4 years, 20% more of all drip tape or drip lines are replaced. At the end of 10 years, all original drip tape and lines have been replaced. So what we're doing is we're giving a person a maintenance point for beginning a little earlier on portions to keep their system. The biggest efficiency degrader in a drip system are plugged lines and cracked lines and eroded lines. So this point, if they're going to stay in the 4 point system, at 10 years, they're going to have to do 100% of it anyway. By letting them start it on a schedule, it helps the efficiency, increases the conservation that's subject to that technique, and gives the operator who's trying to shoot for that an extra point for his desire to be at maximum efficiency and conservation in his system. So there we have 3 BMPs under approved irrigation water management practices that are for 3 different systems that give a point because of the high level of committed maintenance that is committed to. By the way, this is a BMP point. When you write it down, you're committed to it. And every one of these is absolutely auditable. And so that is the first 3. That's the biggest change in the entire category 3. So I'd like to ask for questions on those points at this time. Anybody at all?
Rodriguez, I don't see any questions or comments in the chat box.
Okay.
So Chairman,
we will, as I see. Yes, sir, Director Goski.
I just want to say this, so far this has been very enlightening. There's a lot of information here. It's clear you thought this through very well and worked very hard on each word in your new definitions. I think we haven't heard a lot of conversation, despite, I thought, your great attempts to verbally describe this and spur the conversation. I think some of that is, certainly for someone like me, it's a bit overwhelming. And we're going to need some time to see the written materials and think about it. And I think that will allow many of us to give you a lot more feedback than you've currently heard.
Oh, I fully anticipated that would be the case, and that is the way it should be. Not having text in front of you to where you can give prior thought to it definitely has a negative side to it as well. But in this particular case where we were doing comparatives to existing text and talking about changes on a point-by-point basis, I thought it was best to get this whole thing out in this fashion, and then it all comes out in writing.
And I would just encourage everybody, and maybe at the end we'll talk about a process to get comments back, because I think it is really important for people to really think about this, get those comments back for us to have the next discussion, which is levels of support for these changes.
Very good. We don't have much left to do now, so I'll get us through the end of it. We've discussed 2 new BMPs in category 3.2 and 3.3. One point that was brought up in our last meeting was in BMP 3.4, the old 3.4. It says angled rows / contour farming. It was brought up that it should also include, obviously, angled borders, because angled rows and angled borders do the same thing. Just one's borders and one's rows. So it was suggested that BMP 3. The old 3.4 simply states the heading angled rows / angled borders / contour farming. Everything else remains the same in that BMP. Going on through the BMPs, the only other point that was brought up in the BMP water management practices was the fact that BMP 3.12, computer-based model using meteorological data, that there was other services other than ASMET. And yes, I know there are, but the way the definition reads, it doesn't say that you need to use ASMET. It says that that's an example. ASMET is an example. I agree that there are other systems out there, and I agree that some of them might even be better than ASMET. But by the same token, we've got in the definition that you're using something that does the same kind of things as ASMET does. So I personally, myself, I don't know why there's a need to change that definition. I agree there's other services, but I think this definition as it exists allows that leeway already. So I'll just move on to the category 4 practices, and I have no points to make there at all. There were no points there at last meeting, and I see no points there at this time. So that walks us through the entire worksheet, and let's see where we are with questions at this point.
Chairman Riggins, I see here that Mike Copperosso would like to comment. Mike, you're welcome to unmute yourself.
Well, I got my video working. Hey, Chairman Riggins, I have a couple things in category 3, if we can back up on that. I wanted to discuss.
Certainly.
I was thinking of another BMP, something that might have been maybe neglected or maybe it's inherent, I don't know. But what about water measurement? There really should be some type of BMP point. I mean, for irrigation water management, if you don't know your flow rates, you really can't do water management very well unless you're irrigating from siphon tubes. So maybe there should be a BMP added for some type of an addition of a flume or a weir or district sparling meter, no matter, I'm not sure of all the techniques that are being used out there now, but maybe a water measurement could be added in to get a point under irrigation water management. Maybe something we can discuss. Go ahead.
Mike, you are correct as you can be. That is an incredibly important BMP. However, it does already exist under the current numbering. BMP 3.10 is to measure flow rates to determine the amount of water applied. And
good morning. You got it.
Okay.
It must have been a dream. Sorry.
But you're as correct as you could be. It's very difficult to know what you're doing if you're not measuring it. So
that's correct.
Very correct.
So that's there. The other one was under the where we're talking about some of the weather-based meteorological data. And I know that there's a lot of opportunities out there for even farmers to buy their own weather stations and incorporate computer-based, even cell phones can be used for irrigation scheduling and monitoring of weather data now. But anyway, the point was that it's not restricted to just ASMET. It's an example in this BMP. Like you said, I'm not exactly sure if it needs to be emphasized any more different than that, as long as the applicant can say they're doing some type of meteorological data analysis for scheduling of irrigations. So I think enough said on that. Back on the old 3.8, if we can go up just a couple. It's showing participation in a consultant or irrigation district sponsored irrigation scheduling service. I think that might be somewhat misleading because of the ADWR grant program, which is, using like an IMS team in Pinal County, in Pinal AMA. We've had down in the Tucson AMA where I've worked and have programmed down here for irrigation conservation assistance programs. I don't think that, basically what I'm saying, it doesn't necessarily have to be restricted to a consultant or an irrigation district. It could be an opportunity for any irrigation management service that could be either hired or offered even through the NRCS to the farm. So I think it seems to be a little restrictive there. It should be maybe a little bit more inclusive. So maybe just a little word tweaking there in the future. And really, that's about all I had, except I'm not sure if this is relevant or particularly relevant to farming other than maybe on orchards. But some orchards I've known over the years have gone through bubblers into their process to kind of a modified trickle system, I guess. It's just a PVC pipeline that is based on head pressure, and it just provides water to the orchard through. I don't know if that's a BMP that needs to be incorporated to cover anybody that might be operating an orchard. But those are some things I just picked up on when I was reading through this application process.
Mike, one thing I would state on your last concept concerning orchards and having bubbler systems. One of the things that got stuck in both of the second categories, the third and the fourth category, was the ability to have a substitute irrigation water management practice. So that was the ability of someone who had a system, let's call it a bubbler system in an orchard, to talk to ADWR, talk to the BMP advisory committee, and if they can sell their system as a very high efficiency, high conservation irrigation system, or practice, then that's something that could be included under the substitute practice category. So it was something that was left open to take the ones and twos and threes that aren't done very large, but might exist out there, and for their own merits should be included.
Chairman Riggins,
Yes, sir.
this is Brian Hartman.
Yes, Brian.
I just wanted to, if you could give Ed Martin, Dr. Martin, a chance to speak on the computer-based modeling. I agree with your assessment of what you said earlier, but they did have a meeting with our professional educators, and I'd like him to update us.
Dr. Martin, you there to speak with us?
I am. So,
please go ahead.
Oh, thank you. Yeah. I met with the ag agents from Cooperative Extension that work in the Central Valley area, and also with Kelly Thorpe from USDA ALARC over there at the Maricopa Ag Center, as well as many of our cohorts across the West. And we started coming up with a list, Chairman Riggins, on all the different irrigation scheduling programs that were available, and the different modalities. As Mike said, you can get it on your phone, you can get it on your computer. And what we came to the conclusion is the same conclusion as yours is, we don't want to start listing a whole bunch, because then you're going to leave something out. What you have listed here and saying incorporates real-time meteorological data like ASMET is perfectly fine. And we felt that, being more general in the way that you put it allows the growers to choose the one that works best for their system, whether it be a center pivot system or a drip system, or even a surface system. So we kind of went around the horn and kind of came all the way back to the conclusion that you did, is that, yeah, there's a lot out there, but probably in the end, it's best to keep it simple and just say you find one that works for you and you're using real-time weather data. Well, that's good enough. That's a great, that will suffice for meeting this BMP. So just thought I'd give you a report, because I told you we'd meet, and we did get together and talk about that.
Thank you, Dr. Martin. And I think we find ourselves in complete agreement with each other. I think the way it's written, it gives the details of how the thing should run, gives an example, and there's others out there. It lets people find things that do that as it's listed. So thank you very much thank you for your efforts.
Thank you, sir.
Okay, if absent any other questions, we have gotten to within 9 minutes of our adjournment time. I don't know if we have time at all to get into tiers concepts, but if Natalie, I'll let you give your opinion on how we should proceed.
Sure, Scott, thank you. What I would suggest is maybe we'll skip this presentation, but I kind of have two pieces here. One, I would really recommend that ahead of our next meeting, everybody go visit the 5MP concepts page. We do have a summary and description of this tiers concept that I was going to discuss on that web page on ADWR's website. So that is available online. I would really request that all of you review that ahead of our next meeting. The other thing is Chairman Riggins, if it's okay with you, I would propose that ADWR can send out a questionnaire requesting some feedback on kind of the details that you laid out earlier for the specific BMPs, and also some feedback on the tiers concepts, the types of things that we can focus in on in our next meeting.
That would be fine. As I say, I will be getting the written concepts for this out, and so everybody can start reviewing them. I'll try to have it done just as early in next week as I possibly can get it done, and we will start getting concepts back. I think one of the only things that I might like to point out at this point in time is due to the timelines that were brought up at the beginning of the meeting. This next interval to our next meeting might need to be a little shorter than the last one, because it seems like we're in the middle of things right now, and at the intervals that we're discussing things, we might well be running out of time.
Chairman Riggins, this is Director Wachowski. I agree 100%. And I hate to be that person who says to everyone, the success of this process relies on you doing a bunch of homework, but it does. The homework is what Natalie just described, getting back to us on the chairman's proposals, reviewing Natalie's otherwise would have happened today presentation on the tiers. And I think that will make our meetings more effective and accomplish getting closer to closure and on different proposals, including the chairman's new proposed BMP points, definitions, et cetera. So I'll just again implore folks, please do your homework. We really do need to move this forward, and we don't really want to run out of time. We kind of went down that path in the fourth management plan. I'd like to not have to go down that path again. Thanks everyone for your understanding on that issue.
Natalie, is it appropriate at this point in time for us to go ahead and ask what our next meeting time should be?
I think that would be appropriate. I just want to point out, Amanda was nice enough to pull up our kind of work plan and timeline slide. We had shown a version of this at our previous meeting, so we wanted to kind of provide an update here and also bring this back to this group for kind of consideration and potential adoption here. So I guess I would just maybe be interested in hearing from you, Scott, whether we have kind of agreement on this general timeline. Obviously, we're kind of adjusting things as we go. We'll have to continue discussing those individual BMPs in the March meeting. But at least as a general timeline and with a deadline for recommendations at the beginning of May, do we kind of have agreement on this work plan is my question.
Well, the director has given us a task, and he did at the beginning of this, that we are trying to have this wrapped up the best we can by the 1st of May. What you've put out here for the timeline reflects that initial concept that I understood right when we first started. I believe that with today's meeting, the next meeting we have will tell us a lot of how much work we have to do. And I would suggest we have this meeting in 2 weeks, and we have basically our agenda items are discussing what was presented today and talking about a tier proposal. And I think those are the places we are now. We may find there's a lot of discussion to be had. We may find there's not as much as we think. I don't know. It remains to be seen. But I do believe that we should try to be somewhere in the 2-week time frame on this next one. That gives people plenty of time to think about this, discussions to be had, and get ourselves to where we're ready for a meeting to where we see just exactly how much there is still to be talked about.
So, Mr. Chairman, might I suggest next week you will have sent to all of us your written proposal if we give people the rest of next week and then 2 additional weeks to both comment on that proposal and the tiered proposal, which people need to look at on our website, that would bring us to a meeting the week of March 15th. Does that work for you, Mr. Chairman?
Well, that's March 15th. We're at almost a month. Any way we can get it in the week prior?
So I'll say this, Mr. Chairman, if you can get your written proposal to us by Monday, by close of business Monday, that would give everyone almost 2 full weeks to look at it and move what I proposed up by a week. But if you can't get it to us till late next week, then that's
No. I understand. I understand with all the things going on. I will make a commitment to have emails of this to the department and to Chelsea by 5 o'clock on Monday, the 22nd.
So then, Mr. Chairman, we will look for comments by March 5th, which I believe is a Friday, and then look for a meeting early in the week of March, what would that be? 6, 7, 8, early in the week of March 8th.
Now, the 10th or 11th would be good time.
All right, we'll look at those 2 dates.
Yep. That's 3 full weeks from today.
And I hate to put the onus on you in terms of your written materials, but they'll be key to be able to give people some time to really dig into it and get their comments back to us.
I would say that, oh, sorry, I just wanted to point out that we do have a different 5MP safe yield meeting on the 10th, so I might recommend the 11th.
That 11th is fine. 11th or 12th is fine with me. That's not a problem.
Chairman Riggins and Director, before we adjourn here, Mike Caparoso has a question. He's wondering what is the status of the Ag BMP committee appointments?
That would be a question to the director because I have no idea. Director Buchowski?
So I am not 100% sure status, but I know that the boards and commissions has been pretty prompt in making those appointments when folks that were interested have put their applications into the process. We'll double check on that, but I don't know off the top of my head how many of the positions are still hanging fire.
Director, this is Carol Ward. We haven't gotten any feedback from boards and commissions at this point. I will follow up with them and see what the status is.
And as we have discussed, would be lovely to have some of those done. By the same token, we have a job to do and we just go forward until it gets done.
And since there's not really a formal need to have those appointments made, we can do our work without those appointments being made. We'll continue to try to get them made in a timely manner. But the folks who are going to end up being appointed, those who've applied, et cetera, can participate in these meetings, I think, in fully as if they were already appointed. We're not doing voting. We're not doing any of that kind of stuff. We don't have to have a quorum. Again, I just implore everyone to participate fully as much as they can, and I think the appointments, et cetera, will fall into place. But like the chairman just said, we got work to do. We're capable of doing it with or without the appointments, and we'll do our best to work with the governor's office to get those done, but it shouldn't impede our progress. So I don't think we have anything else, Mr. Chairman, from our side. If it's up to you now for closing remarks or adjournment.
I have no closing remarks concerning any of the process that we've just been through today. I, again, would very much like to thank all the participants here. We have a good number of people here to be observing this and also putting comment into it. And I thank them very much for being participants. And I also wish to thank the department for hosting this and making the forum available, and all of us looking forward to try to come up with good regulatory policy. And looking forward to seeing you all in 3 weeks.
So thanks, Mr. Chairman. Just one last ask by the director, and that is, for those of you who have participated today, if you have colleagues that you know might have some interest, please pass on to them our work plan that we just discussed. Direct them to our website to get the information they need, to comment. I think that would be helpful. I see a number on the screen of 33 participants. I think we've had a larger number of that maybe in a prior meeting. But please reach out to your colleagues, your friends, et cetera. The more participation we have, the better.
Well, Director, if you don't have any other comments to make, I would suggest that we go ahead and call the meeting an adjournment.
All right, thank you, Mr. Chairman. We'll be adjourned then.
Thank you very much. Bye-bye.
Thank you.